failure, and it's some person who wrote a particularly bad line of code that tried to put a 64-bit number into a 16-bit space, and that made that number invalid. So that's another way to look at this particular problem. So the investigation continues. How on earth did that happen? This is a $7 billion project, a 10-year project. They got lots of people on it. Were they really so incompetent? Well, something went wrong, but what was it? So let's look at the code. All right, there's lots and lots of code in this system. That should be very clear. We looked at every code, every piece of code, every operation that could give rise to an exception. Now, actually, the programmers did this. The software developers did this as well. So they analyzed all of these operations, and in particular, they analyzed this very one, the conversion of floating point values to integers. And they determined there were 7 variables that they were at risk of leading to such an error. So this is before any rockets took off, before the ARIAN-5 anyway. In Ada, you can add protection to variables. So in other words, if there's an exception, it will compile or tell you, or something will tell you. Protection was added to 4 of those. And evidence is actually in the code that that was done. And they specifically considered the other 3 and said, we don't really need to protect those because their values will always be in range, in a certain range. The decision to protect those variables was done jointly by a bunch of project partners at several contractual levels. Not just one programmer. There's a whole bunch of people here. There's several project partners, including the European Space Agency and a whole bunch of other ones, who all said, that's okay to do. And at several levels of the contract. So maybe I don't know what the details are, and we haven't been told. But so a decision right down at the bottom of this software is made and is represented in some contract and decided upon explicitly by lots of people. So that's one thing to notice. And another thing to notice is that, as I was saying, this is the booster rocket code, and it's actually, that code is not really required to be running. Why are we running that code? It's just the booster rocket, this is the code that is meant to stabilize the rocket if you abort the liftoff. So the idea is you can release the rocket from the platform, and then you fire the rockets to launch the thing, but if you decide to abort the thing in the meantime, these booster rockets have got to keep the rocket vertical, so it doesn't fall over. And if you abort the thing, you've got to keep that running for as long as you can until it can be reattached to the platform. So that's the alignment thing. So that period is 50 seconds. So you've got basically 50 seconds to grab hold of this rocket before it topples over. So that's what these booster rockets are for. And notice this one. Why is it 50 seconds? Well, that's what the ARIAN-4 required. This is the ARIAN-5, not the ARIAN-4. And that was done 10 years ago. In the unlikely event of a cold in the countdown. So be pausing the countdown. I wonder if this thing's working. Okay. So what actually really happened, a bit more detail, was this. That there was some code reuse from the ARIAN-4 software. So we're trying to trace back, remember, how this line of code got in there. So it turns out now, not only did a bunch of people authorize that it should be there anyway, but it was previously there in the ARIAN-4 rocket. And we'd had no problems with the ARIAN-4, had we? Because in ARIAN-4, flights using the same type of system had no such failure, because in their first 40 seconds, they actually couldn't reach the high speed that would cause this exception. Unfortunately, the ARIAN-5 had a higher initial acceleration, basically went faster, and therefore its velocity did reach the higher number within that time frame. within actually 40 seconds, the time that we're still running these other booster things. So there's another piece of the puzzle. We're actually reusing code from the old system into the new system. Of course, code reuse, that's something we talk about quite a lot. And as a generally good thing in software engineering, you don't want to be rewriting stuff all the time. So what actually happened was a little more like this. Well, these are all things that have gone wrong. Not just one line of code, but all of these things. Duplication of a component to provide a backup was what you do for hardware faults, not software faults. Okay? So in other words, software failures do not have the same characteristics as hardware failures. So when one of the systems failed, these SRI systems, then the other one failed exactly the same way, because they were working correctly. Now what about testing? Here's where we might say they did really poor testing. The SRI was not tested prior to the launch. Why is that? Well, it was considered, by somebody we don't know, fully qualified at the equipment level. In other words, this is good equipment. Hardware kind of view. Didn't test the software, just said it's good equipment. And so they didn't bother testing it. In particular, they probably, I presume, they didn't test it with the Ariane 5 flight data. So in other words, the specification of that thing, the requirements document, did not contain the Ariane 5 trajectory data. Only the Ariane 4 trajectory data, which as we already saw, differs from that of the Ariane 5. So even if they did do testing, which they probably did, not of the real rocket though, in simulation perhaps, they would have tested this component on data for the old rocket. Unfortunately, they didn't test it on data for the new rocket. So Bertrand Meyer, who you've done 2911, I talked quite a bit about, he's the guy who wrote the paper on design by contract. This is a slightly different 97 paper that talks about that in the context of Ariane. Calls this a reuse specification error. In other words, we didn't specify the requirement anywhere that in any document that the horizontal bias should fit in that 16 bits. We actually said it somewhere, well, it was actually specified in an obscure part of some document, but not in the code itself. So the people using that code wouldn't have been aware, or may not have been aware, of that particular limitation on the use of that code. So he's calling it a reuse specification error, as in, well, I'm not quite sure what he means, but we somehow did not specify enough when we could reuse this code, the conditions under which we could reuse this code. So now when you look at that software failure, and this is typical, so this is what will happen, it's exactly already what happened in the case of these babies who got the wrong gas. There's a whole chain of events. A whole chain of events, and a whole bunch of people, and a whole bunch of contracts, and lots of little things that go wrong, and all of them add together, and something bad, really bad happens. So this is why when you say, well, who can we blame? Now, blaming is something sometimes you want to do. It ties back to our ethical question. You want to blame the guy who did the wrong thing. Well, what's the wrong thing? Who here did the wrong thing? Well, when you look at it, nobody actually did the wrong thing, necessarily. Maybe some of these guys who signed off on the variables did the wrong thing. Maybe they did testing, but by themselves, that wasn't enough to cause the whole problem. Maybe there's some things that were done not very well, but there's no one person, well, there may not be, maybe I'm guessing, but there's no one person whom you can say, yep, that's the guy who did the wrong thing, and so he's going to be punished. And that's probably the case for most of these sort of errors. Most of these errors result from a whole series of coincidences and random events, and just bad luck almost. But that's not to say that people should not be taking care, and they took all care. All right, so that's why software failures. One reason, that's this kind of complexity of software and the difficulty of planning and stuff like that. That's one reason we focus a lot on software quality, particularly for the STEM students. in this course. So let me ask you a different question. I hope you know the answer to this one. Some people look like they're getting a bit tired. I'm going to check the air conditioning. It was running before. So what's good? Come on. It says it's running, but it hasn't, there's not a timer countdown, so maybe it's still running. Alright, so what's good quality software? No. So how would you describe, okay, so we want, what's your aspiration? You know, you're going to, you know, how do I, okay, so this is the kind of question we ask our students, and we'll ask you as well, at the end of your project, is this software good? You'll of course tell me it is. And I'll say, okay, why? Tell me why it's good. Give me some properties of your software that convince me that it's good.
Well tested.
Tested, yeah, but that tested doesn't necessarily make it good. But maybe what you mean is you've removed some bugs from it, bug-free. So being correct is a good thing. If your software actually works, that's a good thing. That would make it good, partly. That's only one thing though.
It's efficient.
Efficiency is good, definitely that's good.
It achieves its purpose.
Very good, yes, it's got to be fit for purpose. Whatever that is, yes, exactly. Anything more?
Well documented.
So yeah, it should be understandable as well. So even let's say understandable. Not just well documented, but how about easy to understand code? Anything else? Modular is, yeah, could be a bit technical, but yeah. So you have to convince your manager. I mean, manager maybe doesn't know what modular means. Maybe you can expand on that. What does modular mean?
You write the software in such a way that you need to upgrade particular parts of it.
Yeah, that's a good idea. That's much better. So that relates to this maintenance aspect of the software. Yeah.
Revisions, so you get multiple copies out.
Yeah, that's more a practice though. That's how you did it. I want to know whether it's any good, what the outcome is. So I could have had a lot of revisions of bad software.
Stable?
Stable, yeah.
It doesn't change under the user speed when they update.
Yes, that's good. So stable is good. So that sort of relates to correctness, but also other things. Anyway, let's see what the textbook says. This is figuring out like a different software engineering textbook. So let's look at the things in blue on the left. You missed out usable. So it's got to be correct, it's got to be reliable, it's got to be efficient. They're saying something called integrity, we'll look at that. Usable. You forgot, remember? If the software cannot be used by anybody, then you're going to fail. So it's got to, for the software to be good, it's got to be easy to use by the people who are using it. Maintainability is what we were getting at here, thank you. Testability. So we'll look at what these maybe mean. I'm not sure that these are very precise terms. Flexibility, portability, reusability, and interoperability. So they're saying, now here's where I think the things are a bit dodgy. Things on the right are supposed to be more technical things that feed into these sorts of almost requirements for good quality software. So things like, you know, let's just pick maintainability. They've got a whole bunch of things that says, is it self-described? No, is it well documented? Is it modular? Which is what he said. So that's what I was saying. So what you were saying there, what some people said were more technical things that give you some of these more high-level qualities of good quality software. And usability, they talk about training and communicativeness. Well, it's probably a little bit more to it than that. So these things on the right, a little bit greater soft. But yeah, so talking about reusable on different platforms, or as the stable would mean as the technology changes, we can still run our software. That would be a good thing, etc., etc. General means we could reuse bits of it as well as modular. Concise means we wrote the code, you know, nicely. You know, nice compact code, easy to understand code. I would put in there somewhere. Not sure it's there. Anyway, so those are the sorts of things that we want to aim for in good quality software. Let me just say a couple of things. So this is sort of moving on to the software project management. So the first question is, well, what do we try to do? We're trying to produce software that has these qualities. So this is a really old slide from a 2010 textbook, but the year goes up to 1985. So let's just look at this point though. We wanted to ask the question, how much of software development is Oh, this is a different one. So this is the relative cost of hardware and software. So back in the old days, before even I was born, hardware was really expensive. Of course, these days hardware is really cheap. But the key thing here is, so in other words, software is a greater cost. No one probably worries about hardware costs now, maybe even in some of these cloud systems. Even then, you probably still don't worry about the cost of hardware. Software is the bulk of the cost of any system, but the key one I wanted to use this slide for was maintenance. So when we think of costs here, and when you think of costs in your project, you're probably thinking of the development cost. But it was well recognized yonks ago that maintenance actually is the greater proportion. In other words, not just we shipped the product and that was it, but what you do with it afterwards. So that is the majority, according to this funny slide, but no, don't believe the numbers, but the majority of the cost of software in the software industry would be maintenance, constantly fixing bugs, releasing new products, updates, and all of that. So even though the landscape probably changed a bit since then, probably the cost distribution hasn't changed quite so much. There's still a high degree of, you can't just sort of build your system like a university project and hand it in and that's the end of it. Rather, you've got to maintain it. You've got to keep your customers happy for a long time, or they're going to go somewhere else. So the next question is why do software projects succeed? So we already asked why they fail. So one of the answers could be the opposite of those answers. But this is just a kind of Mickey Mouse survey, but why do software projects succeed? When they succeed. Okay? No checking Facebook. So what's your answer? What's the number one reason a project would succeed, do you think? Hmm? Yeah, I already said usability is one thing. Yeah. Of course, you're meant to be competent professionals. You're going to go in there and say, my project will succeed. So why is it going to succeed? How are you going to make it succeed? Yeah.
I was going to say it meets expectation.
Yep, exactly. So that's one thing, but it's got to do what the user wants to do and expectations of whoever. Yeah.
Within time and budget constraints.
Yeah, it's got to also happen within time and budget. That's a prerequisite for a successful project. Yes, but that's more a constraint rather than actual. Why does it succeed? Let me think at the answers. Yeah, okay. So the answer they've got is realistic budget. So in other words, if you've got a realistic budget, then you've got that's a prerequisite for success. And that might also extend to realistic time. Yeah. Anything else? I'm not job ready, are you? Your manager's going to ask you, why should I trust you to deliver this project?
The requirements are well understood and static.
Yep, that's the first thing. That's requirements. Let's not say static. We haven't listened to the Agile course yet, but requirements aren't static, but they're well understood certainly, and hopefully stable. Let's go to that. Let's show you what they said in the survey. So number one, clear requirements and specifications. So now, yeah, maybe, I think Agile doesn't change this a bit. This is still the case. And, you know, for John and Sandeepa again, when we go to talk to our defence partners, what do you want us to build? They don't tell us anything. Partly because they're sworn to secrecy and they can't, but also they don't know. So when we say, well, what if you did this? Is that good? They don't say yes or no, they just give some answer. But essentially, if you've got to get really clear on what it is the requirements for your system are. And certainly within a large project, if you've got 10 people doing different things, then you'll not necessarily come up with something that does meet, that is actually a coherent system. So that also relates to clear objectives and goals, I guess. So what do we actually, is there a clear understanding of what it is this project's meant to do? Is the schedule realistic? That's the question up here. Have we got effective project management skills in this project? In other words, can we get things done anyway? Do we have support from the top management? Do we have involvements of the clients and the users? Do we have effective communication and feedback? Do we have a realistic budget? Do we have skilled staff? You forgot that you're very competent, so that you're very important to the success of the project. And the frozen requirements is there. Now this was done, I guess 2011, but think of this in terms of a really big project, not necessarily the sort of thing you might do. And this is why, in a small team, this is why we ask the Atlassians of the world, how does that work with a big project? Because they have lots and lots of people working on lots and lots of things. Familiarity with the technology or the methodology, and proper planning, and a few more. Don't rely on any numbers here. So I'm going to give you now a bit of this is a rundown on software engineering. This is the 3 lectures of software engineering that I'm going to compress into about 5 slides, maybe a few more. Let's just say a little bit about requirements, and then we won't talk too much about requirements again, but they're all there in the background. So hopefully those of you who don't understand will know about functional requirements and non-functional requirements. This is still sort of used terminology, I think. I'm not sure, but let's go with it for a while. So the functional requirement is going to say what the system's supposed to do. There's supposed to be a distinction between these sorts of requirements as well. I'm not convinced that there's a good distinction. And it may state what a system shouldn't do. So there'll be a whole bunch of, you could ask the users, should the system do this, should the system do that, should the system do something else? And we will get to Agile in a while, but the point of that is maybe a little bit too premature because, asking the user what the website should look like, for example, should this page be colored blue or red, that's probably a bit premature and we don't quite know what the system is yet. But nevertheless, a functional requirement is something like that. Think of the rocket again. So a non-functional requirement relates to things that we are obviously not relating to the function. So in other words, things they mean there are efficiency constraints, time. In other words, this has got to work on this platform, so platform constraint maybe. Timing's got to be responsive to user presses and all that sort of stuff. And this may apply to the system as a whole. So this is the received view. Somerville has the 10th edition out now, so I've just kept the reference to the 9th edition. And so functional requirements might encompass all of these things. So at a high level, when you're tendering for a government project, you might have to think about the legislation. You might have to think about making this thing safe. You might have to think about the particular operation, what's going to integrate with. Usability, performance. What other things does software does this depend on? Etc., etc. What are the requirements of the organisation? And non-functional things, according to Somerville, I don't believe this either, but things on the right might be ways of demonstrating the things on the left. So there might be a non-functional requirement for speed. Okay, so the user says things like, I want my thing to be responsive. You have to turn that into something that you can measure and prove that it's responsive. So you might say, oh, does that mean I need to process 1,000 things per second or 10,000 things per second? And maybe that's an important question because it'll make a difference to your answer, to the way you do your whole system, depending on what the answer is. So those sort of idea here is, okay, how can we get at what the user's requirements are if they are non-functional? So we could try to turn into a specific. Now again, one of the problems with this is that users can't necessarily answer that. They might not know, or they might have to. So in other words, if you guess wrong, then it won't help anybody, and your software will not be used. So you might think you're being smart, as in, we've documented that we have to process 1,000 things per second, and the user has said that. And in fact, it turns out that it really was 10,000, then your problem is that your software won't be used. So yeah, you fulfill the contract, but your software didn't get used. That didn't really help you. So that's where you have to somehow anticipate what the users really want. And the users are just users, they don't know. So we're talking to guys who are federal policemen. If I ask a policeman how fast their software is going to run, they haven't got a clue. We have to get it right for them. So we can make it even more specific what the problems are, and I'm sure you can understand here. Elicitation problems, the stakeholders don't know what they want anyway, so that's the first problem you have. That's what we have in our project. The stakeholders don't really know, or don't know what they really want. They express their requirements in their own terms. I want a system that will, let's say, help me do my tax return. What will that mean? Well, we have to figure that out. Different stakeholders have different requirements. So lots of people might be interested in your project, but they all have different opinions or different requirements. Organizational and political factors influence those requirements. So, you know, when you ask one person what they want, they'll say, I want a system that does my job for me. You ask another guy and they'll say, I want a system that does my job for me. In the end, they're doing different things. You can't get a clear idea what this system is anyway. Now, the key one that Agile's supposed to address, requirements change during the analysis process. So, but we still have to have this analysis process. So this whole thing, how do we manage a big project? How do we get this project off the ground when the requirements are changing, but they're now actually changing during this initial process, maybe even this initial discussion process. And new stakeholders emerge and the business environment changes as well. All right, so what are those sort of changes in requirements? There could be lots of different sorts of things. So new hardware might come out, so a new phone, like the iPhone came out one day, that changed things quite a bit. Integration with different systems, change in business priorities. So in your company they might say, well, okay, we're going to jump doing stem cell research from now on, so that's it, you guys are fired. Or climate change research might be a better one. People who pay are usually not the users. So, you know, you get hired by a company to do a product, but the users are not those people. So you say it's an insurance company, we don't know, or they don't know, whether the end users will be happy with this system, unless they find out. And it's a bit of a disaster if they release some system and it turns out the users can't handle it. And you have a real problem. That shouldn't happen. Diverse user community with different requirements. So here, there's not just one single user or user group. You've got to build one system for everybody, and not necessarily make people, all of those equally happy. So that's the gist on requirements. So now I'm going to talk about. So we thought this course is supposed to be about software project management. So here's the thing about software project management. So I'm going to talk about the sort of the high level, the sort of intermediate level, and then the sort of low level. Now you probably have most familiar with the low level at the moment. So in the high level, management of a software project involves maybe thinking about a lot of things. This is the traditional view. Risk management, what could go wrong, managing people, and how we're going to organize our company, and teamwork skills, as we will come to, that applies everywhere. There's the project planning side of things. Now there's actually how we're going to price this software, what is the plan going to look like, how we're going to schedule that plan, amongst all the other things we're doing. What is quality management going to look like, and what is configuration management, development of the software going to look like. Some of these may be related to the software itself, some of them a bit higher level up in the organization when you're talking about multiple software projects. So it's not quite so clear cut. So my inspiration comes from Dilbert mostly. So here's Dilbert on this. Why have a plan at all? Why do you need a plan? We don't need a plan, nothing's going to go wrong. That's the first thing that's wrong. We don't anticipate any mistakes. Oops, no. We must anticipate mistakes. So here's Dilbert again on why we need a plan. Well, not exactly. This is the bad side of doing a plan. One of the Atlassian lecturers 1 year said in his former job, not at Atlassian, they spent 18 months negotiating the contract. 18 months, and they weren't paid until they presented them with a document on what this project was going to be. That document was about, I think he said, more than 1,000 pages. After that, of course, they never built any software. I think they got paid for the document though. So this one is saying there's lots of ways. So planning can be bad. You know, we've done a lot of faffing around and have meetings, but we haven't actually built anything yet. So that's the flip side of it. You know, I haven't done anything yet. I've just done some waffly stuff. But yeah, there is a serious side to that one. So let's see what a traditional project plan looks like. So those of you who done Agile know what's coming. This is not the way to do a software project. Didn't know I had animation. So, we actually had one of these. So I did a software project ourselves in a previous CRC, and they made us fill in this. We had to have a version control system for our document, the history of this document, the distribution of this document. In other words, who was allowed to read this document and who wasn't. We had an introduction. What was the purpose of this document? And I made them out a glossary because there were so many acronyms in there. I said, we need a glossary. Okay, let's put it in. Project definition. What is the background, the objectives, the benefits, the KPIs, the scope, the assumptions and dependencies and the deliverables of this project? What's the implementation plan? High-level schedule, milestones, approach, quality plan, and completion criteria. In other words, how do we know when we're finished? Who are the roles? What are the roles in this project and the responsibilities of the people carrying out those roles? What are the high-level requirements for this project? What's the timeline? What are the risks? What are the other documents we have to read? What is the naming convention we're going to use? What are the meetings we're going to have? What are the reports we're going to write? And what is the post-implementation review going to look like? So that's what you have to do if you're writing a traditional project plan. Maybe some people still do that. And you're supposed to do that before you've written any code. So Agile doesn't make you do that because basically you can't. You cannot possibly write that document, but yet you have to. There are tools, so I'm going to tell you what these tools are. And this is, if you're doing a course on project management in an engineering school, or maybe even in a business school, they use these kind of things. So PERT chart is a method for, if you've done an AI course, it looks like an AI kind of plan, where the little boxes are, the boxes are not tasks, sorry, the boxes are milestones, and the transitions in this one are tasks. A bit like a non-linear plan. So the numbers reflect time, or something, probably time. So this is a PERT chart, which I learned from Wikipedia, was invented by the US Navy. And what they do is come up with this chart of all the activities we have to do in this project with the dependencies. Now, all of that assumes that the requirements are stable, because after all, this could be quite long, it could be years long. So that's a PERT chart. We won't use those in this course. A Gantt chart is something that some of you might be familiar with as well. This one's a bit similar, but this time on the left is the color-coded one, so I really liked it. On the left, it has a bunch of activities, and in the chart itself, it's when those activities will occur, and who's going to do them. So you get little stars for milestones, and you get the marketing team doing the green things, etc., etc. So as we know, again, and I'll say this for Agile, this is a work of fiction. There's no way you can tell me what you're going to be doing from November the 8th to November the 22nd. You certainly won't be doing that. You'll only be doing that if everything works to plan, which it won't. So here's how not to do a project plan. So back when we used to start this course, this is the past students' project plan. We used to give them a choice to do Agile or something else, this sort of approach. Generally speaking, but not always, the ones that do this kind of approach didn't do very well. So that's why we don't do it anymore. Now this was a particular, I sort of changed things, so imagine this was some kind of Android game, I'm not sure exactly what it was. But their plan was a 6-week project, so week 1 means that we're going to set up. So let's say that meant I'm going to learn some Android, I'm going to get my phone, I'm going to, whatever it is, right? And then do most of the project was, okay, we're going to develop the game, and there were some subtasks in there, but they were not part of the Gantt chart. So the game would be something like, oh, we've got to do some GUI, we've got to do some whatever. But whatever it was, that was that. And then at the end, there were some extensions. So the extensions could be, oh, we'll make it flash red or something. Doesn't really matter. Now, what's wrong with this plan? Now, if you see that plan, and you're a manager, you can immediately see that that is a terrible plan. So what's wrong with it? Yeah.
It doesn't say anything.
No. Assume it does say things. So assume it says that setting up means learning Android. So I'm deliberately doing this so you don't know which student group I'm talking about. So, and the most appropriate would be, we've got to define the game, we've got to find these stupid Pokemon, it's going to light up. Not broken down, but a sort of list of things. A list of things that would require. So what's wrong with this plan? You immediately see this list, you should be, alarm bells are already ringing. No, that's not what's wrong with it, but yeah. What's wrong with it?
Changed.
No, that's not what's wrong with it. Yeah, that's partly there. Yeah.
The setup is too short compared to do most of the time.
That's possibly it, but that's not what's bothered me. Yeah.
There's no testing and refinement.
Imagine there is.
The whole week for extras.
Yeah, that's not a problem either. Yep. No, they assume that they do mean something. I mean, I deliberately didn't put it on so you wouldn't know which group it was. It's actually a few years ago now, so you probably don't know anyway.
They haven't factored in time for mistakes. Like if it's due week 6. That's...
Maybe they have.
Alright, okay.
Yeah, yeah,
They haven't told you how much time it takes to do each thing and what order you want to do.
yeah. So the plan's pretty sketchy. So my real question was this is the agile question you should have asked. What's the first point at which I should expect to see some working software, according to this plan? Correct, week 5. So we told them, this is a ridiculous plan because you will not, you, according to your own plan, you will not be showing me anything until week 5. So when we come to talk to you in weeks 2, 3, and 4, how will you know if you're on track? So it relates to the specificity of the plan. How will you know if you're on track? What did they say? Yeah, they sort of said, we'll know. They said, oh yes, will you? Okay, let's see. So we did ask, what we did was we looked at those lists of tasks and we said, okay, have you done some of this, some of this, some of this? Oh yeah, we've done some of this, some of this, and some of this. Okay? So what do you think happened when they went to the demo in week 6, after week 6? What worked? Okay, let me ask you this one. At the end of week 5, did this thing work? The thing in green? No. Not at all. Not even close. So of course, the extras got jumped immediately, and the week 5 thing got extended to week 6. At the end of week 6, did it work? No, it didn't. Exactly. But even worse, when we asked them in their presentation, going back to your plan, what would you have done differently? They didn't say, we should have used agile methods, because that's what they should have said. They should have done that, because it was something like an Android game. It wasn't necessarily that, but it was something where it would have been really good to have some user input early on. So they really should have had something working down here, and then they would have averted a lot of this other stuff down here. But they didn't do that. And worst of all, they didn't seem to realize that. So they said something like, oh, maybe we should have a better plan. No, that wouldn't necessarily help you. Or maybe we should have been better competent programmers or something. No, not that either. So let's look at do it again for inspiration on the generic project manager. So that's how not to do it. So we won't be doing those plans anyway. Some organizations have generic project managers. Their job is to coordinate the projects. typically not, according to Bill, but not a great idea. But they do it anyway. Our university just hired some as well. Welcome to Dogworks, School for Zombies and Project Managers. The same is the same. The zombies get out more in the sun. Learn your jargon. So that support review meeting, that's actually the words that was used in my traditional project plan, remember? We didn't have one of these on-site postcard of a support review meeting. And we're a certified project management zombie, aren't we? We just had a 3-hour project review meeting. The irony for us is we have a 4-hour project review meeting on Thursday. Anyway, some things you need to, so generic project managers tend to be not very helpful. So just to go back to that story, the project we were doing with this previous company, which we shall not name, required a project manager. Now that project manager didn't do anything except ask us at the beginning of every meeting, are you on track? Because this guy didn't understand the project at all. But we just said, yeah, we're on track. And that wasn't me, that was also us and the guys from the company. The other people doing actual work. So this project manager's job was basically to make sure we were doing things well. And we were, but what we were doing was actually not what was in the plan anyway. It was slightly different. Already the requirements had changed a bit. So after a few weeks, when he said, are you guys on track? We said, yes, we are. But the actuality was we weren't entirely on track according to the plan. That's how it is. But nobody cared because we were doing good things. And at the end, we gave them exactly what they wanted, even if we didn't follow the exact plan. So, this is something that's really important that you wouldn't necessarily see anywhere else. So this book was even old when I was a student, Mythical Man Monk. But this guy, Fred Brooks, at that time had worked on probably the biggest software project that there ever had been, which was the IBM operating system, the IBM 360 or something. So it's got a massive amount. That's a pretty big project. So Fred Brooks says something like this. So there's this kind of bathtub curve, but we'll look at that in a minute. The key thing he's pointing out is that adding people to a late software project is going to make it later. So there's very much if you're building a railroad, let's say, you're building a railroad from New York to San Francisco, and you're behind schedule, you can add people to that project and you can lay more tracks. That's typical management response. We need more people on this project. Well, after a while, that doesn't seem to work because coordinating those extra people gets to be a lot more difficult. That's the red line. So you don't, even though you might think if you double the number of people, you can double the amount of track, maybe that's not quite so. But with software, it's even worse. So not only do you have to coordinate these new people, but you've got to completely rearrange your project. You've got to tell them what they have to do in ways they can understand it. So you've got to reassign all the roles to everybody else. And essentially, after a while, it gets so confused and chaotic that it actually takes longer. It would have been better to not bother hiring anybody in the first place. Just keep the original team, it would have taken a bit longer than it was on plan, but adding these extra people didn't help. Made it worse, in fact. So that's I'm looking at kind of curve. This curve is not from his book, the stuff that's in his book. So that's one thing you really have to remember. So adding people to a project that's already late is going to probably make it later, not earlier. And another one that's pretty nice is Death March. There's a book called Death March. And this guy Jordan wrote the software engineering book that was before some of them. So he's pretty well known as well. He's probably fairly old by now. And Death March project is a project that is doomed to failure. You can tell it's doomed to failure already, maybe even when it's only just started. So how do you know you're in one of these projects? So his thing is you've got to make sure you're not on one of those projects. So his thing is, okay, so politics is the number one reason that a project is going to be a Death March project. In other words, you're not getting any support from that upper management. You're just doing this project, but they know it's going to fail, and then they can hang you out to dry when it fails. So you're the bunnies. So that's one way that a desk master, one way to identify a desk master project. Or naive promises made by marketing senior executives or naive young people, etc. So these promises might be things like, yeah, we'll get that release out by the end of next week, no problem, or we're going to have that phone done by whenever, or we're going to sell this number of phones, whatever. And then you can't actually do it. People who actually need to do it can't do it. So there's this kind of naive optimism, yeah, we can just do that over the weekend. So it's not new to this generation, this guys in much long ago. The startup mentality of fledgling entrepreneurial companies, yes, we just can do more. Doesn't always work. A lot of startups fail, don't forget. Marine Corps mentality, yeah, we don't need to take any sleep here. Intense competition caused by globalization of the markets, well, that could apply at any time, of course. Caused by the appearance of new technologies, government regulations, unexpected or unplanned crises. So typically, as we said before, some software you rely on, the company went bust, or typically your programmers left the company. So 3 of your team just left the company. That's a pretty bad sign. So you of course want to avoid being on that project. The whole book is free PDF download, by the way. So, upper management. Oh, maybe I thought I was going to say this before. Oh, this is the generic manager again. Okay. So not the project manager, this time's the upper management. We need more people on the project, says this guy. And the upper manager says, figure it out. Work smarter, not harder. Make a plan, move some things around.